This is my AI final project with the analysis of the housing data. So we're using Google Code Labs to house my project using Python code and imported the Python library such as NumPy, Pandas, Matplot library as plot, and using also Seaborn. We I uploaded the copy of the dataset, which is the copy of the Ames housing dataset. And here, lower down below, we have the housing data, has the order number, the process ID, and different data based on the zonage. But what we're gonna be analyzing is the lot area and the sale price. I'm trying to scroll over there. The sale price was the last column over here. We're gonna be analyzing the lot area and the sale price to see if there's a correlation between the size and the price. So as we scroll down here, we check for any missing values. And if they are, we drop them. So down here, we have the different years that were sold and the price that they were sold at. So I took the data frame and plotted the year that it was sold, and for the x-axis, and for the y-axis, I plotted the sale price. So the sale price is here. So back in 2006, there was a home that was sold for maybe 6,000, over $60,000, $600,000. And then over here we have in 2007, home went for sale for above $700,000, probably like $750,000. And then here we have the analysis of the lot area, which was on the x-axis, the lot area is plotted, and on the y-axis, the sale price is plotted. Even though it's a little glitchy because we have a huge data set of a lot of homes that were sold over the past couple of years from 2006 to 2010. And down here, I posted a scatter plot of the lot area and the sale price to get a different representation of the views of the process, of plots. And then I have the year built and the sale price. Again, that has an analysis of the size of the homes that were built and the year that they were built and how much they went for, to show that as through time from the 1800s and beyond, the houses are getting bigger and more expensive. As you can see here, the lot area is also increasing for some homes. And down here we have another analysis using, I believe, Seaborn. Well, actually, the data frame was using a histogram to analyze the home size and the builds. And down here I have the different correlations of all the features of a home, like total rooms, kitchen, and all that data. Here we have Seaborn pair plot, which is a huge data set here. So we have the lot area here, analysis of the lot area on this axis, on this row here. Go all the way over. And then the sale price should be further on down at the bottom. See, this is the analysis of all the sale prices. And then this is the area that we're looking at here, is the sale price and the lot area. And you see how the representation of the graph is. As the lot area increases, so does the price. All right, down here I have a linear model of using sklearn for linear regression. So the model is going to fit the data of the lot area and the sale price. And then down here has the model coefficient and the y-intercept. So basically the model coefficient is 2.70 and the y-intercept on the graph is 153,378.892. So if you were to plot this, it would be on, this would be the y-axis right here, and that would be the sale price for the model. Down here, we have I plotted the data points and plotted the graph. Say we have another model where you take the lot area and pack it into values. Unfortunately, this is in not hexadecimal, scientific notation or engineering notation, because there's a difference between the two, but this is still in scientific notation, the home values. I wasn't able to fix that. And we have the sale price. All the values of the sale price packed into the data. So this is a setup for the decision tree. So basically you have two different values here. So I guess this is the decision tree for the lot area and the sale price. So for the X value is the lot area. So if the lot area is less than 10,926.5 square feet. If that is true, it will move over here. And if it's false, the decision tree will go over here. So this is where it analyzes the data and packs into different categories. So here on the true side, it moves over here if it's less than that square feet. Now, if it's less than even 8,639 square feet, it'll move over here to true. And then the sample values will tell you how many homes pack into this area, and it's 1,138 samples. And then the value of those homes is $147,093. Those are like the average values at homes. Going down further below, we have another data set that we analyze is using sklearn for the polynomial features to try to graph. However, we plot the linear regression to try to plot a line. However, that didn't work out too well for me, as I have some error messages. So going down further below, I use the decision tree again, but as a decision tree classifier to use the lot area and the sale price. And here we use a depth of 3. Well, max depth is 2. I miscounted, to plot another decision tree to further analyze the sale price. So for the X values, if it's not under 9,100 square feet, it'll move over here. If it's greater than or equal to 9,100 square feet, it moves to the right. So we have analysis of 256 samples, and one of them none of them can fit that bill because there's all zeros here in the one-hot encoding. So, and over here, one of them fits one of these values here, and I have to figure out which one it was, which one of the leaves are But moving on, I tried to fit another manual model for the test train split that worked out. And this is the data here for that. But my project further froze and I cannot get the scatter matrix to run, and it's been hours. So basically what I did find was that as the lot area increases, the price of that property will increase as well. So people are looking for more square footage for the prices of their homes. And as time progresses, the size of the homes will grow. So this is where I analyze the sale price. And this is the lot area should be over here. And as you see, I have 307 columns, but I printed out the first 5 rows just to show a glimpse of the data set. So this concludes my project, and I hope you have a nice summer. Thank you.